Think of your body as a magnificent ancient city. The buildings are your organs, the roads are your blood vessels, and the daily traffic is your metabolism. Now, for this city to survive 1,000 years, it needs a dedicated repair crew. That crew is your stem cells. When you are young, this crew is massive, energetic, and relentless. They are the master builders. Every time you scrape your knee, they rush to the scene, divide, and create new skin cells. When you get a cold, they replenish your immune system. They are the secret to your resilience. But what happens to that city when the repair crew starts to get tired, slow down, and eventually retire? This is the story of stem cell exhaustion, one of the primary hallmarks of aging. It's not just about looking older, it's about how our body's internal maintenance system gradually falls apart. So, why does this crew slow down? It comes down to a few key biological realities. First, the quota. Stem cells don't divide forever. They have a finite number of times they can replicate, known as the Hayflick limit. Every division shortens the protective caps on their DNA, called telomeres. When the telomeres get too short, the cell can no longer divide safely. It enters a state of permanent sleep, known as senescence, or it self-destructs. Over decades of repairing cuts, fighting infections, and replacing old cells, our stem cells simply use up their division quota. Second, the niche. Stem cells don't live in a vacuum. They reside in specific microenvironments called niches. As we age, these neighborhoods deteriorate. The supporting cells become inflamed and stop sending the correct repair signals. The stem cells are basically shouting into a void. Without the right chemical cues, they remain dormant and fail to activate when needed. Third, the garbage accumulation. Over time, our stem cells accumulate genetic mutations and damaged proteins. The cellular machinery that cleans up this debris, autophagy, becomes inefficient. This cellular gunk clogs up the stem cells, causing them to malfunction and become dysfunctional. What are the consequences of this exhausted crew? It manifests in ways we all recognize. We see slower wound healing. A cut that would heal in days as a child now takes weeks. We see it in our immune system. Our immune stem cells become exhausted, leading to immunosenescence. This makes us more vulnerable to infections like the flu and less responsive to vaccines. It's why older adults are often the most affected by seasonal viruses. We see it in our muscles and bones. The stem cells responsible for rebuilding muscle fibers and bone density run out of steam. This leads to sarcopenia, muscle loss, and osteoporosis, bone fragility, which are major contributors to frailty. And finally, we see it in our brain. Neural stem cells decline, reducing our ability to form new memories and learn new skills, contributing to cognitive decline. Suddenly, the city that used to repair itself overnight now takes months to fix a crack in the pavement. The good news is that because we understand this mechanism, scientists are working on ways to revitalize the repair crew. They are exploring therapies to clear out the zombie senescent cells, to inject young signals to wake up dormant stem cells, and even using small molecules to lengthen telomeres. Stem cell exhaustion isn't just a countdown to death, it's the body's natural rhythm. But by understanding the rhythm, we can learn to orchestrate a healthier, longer performance for the city that is us.